Hi there, I'm Rasmus Puggaard and I'm joined here with Yonatan Goldshtein. And in the next 20 minutes or so, we'll be presenting research that we've done into variation of plosives in Jutlandic varieties of Danish, with the hypothesis that variation in phonetics predicts variation in phonology. And our slides here are relatively Spartan, but for more references and details, you can look at the handout that we've shared as well. So this is an overview of what we'll be talking about. We'll be saying a few words about geosocial variation in Denmark, about the corpus of dialect recordings that we're using, and about plosive variation in Danish in general. Then we'll be presenting two phonetic studies, one looking at variation in voice onset time in plosives across the Jutland Peninsula, and one looking at variation in spectral characteristics of plosive releases across the Jutland Peninsula. And finally, we'll say something about how these patterns of phonetic variation correspond to patterns of phonological spirantization in the varieties that we're looking at.
If we go back to the beginning of the 1900s, around 90% of the Danish population spoke varieties other than the incipient national standard language of Copenhagen. The last 100 years of Danish language history has been characterized by intense dialect leveling, intensifying in the 1960s due to educational reforms, increased urbanization, and a flourishing standard language ideology. Today, Danish has been characterized as one of the most homogeneous language communities in the world. There is a long tradition for dialect geography and dialect description in Denmark, which has focused especially on lexicon and categorical phonology, and less so on subphonemic variation. On the right, you see a map depicting the traditional dialect boundaries in Danish, and these generally represent isogloss bundles, and the dialects tend not to be sharply delimited. Though much of the historical variation in Danish is likely to have vanished, it is today possible to study subphonemic variation in the traditional dialects, mainly due to massive efforts in the 1970s to document the speech of the rural population in Denmark, especially in the period in 1971 to 1976, where recordings were made in several hundred villages in Denmark, represented by the red dots on the map to the right. These recordings consist of sociolinguistic interviews. The speakers represented largely conform to the norm ideal in that they are non-mobile, old, rural, and male. However, there are more women represented in the material than in some comparable corpora. The average age of speakers in the corpus is around 70 years, meaning that most were born around the turn of the century. The dialects, the recordings of the insular Danish dialects have been used for lexicographical purposes, but the Jutlandic recordings have never really been used for scientific study.
In standard Danish, there's a phonological contrast between voiceless unaspirated and voiceless aspirated plosives. Voicing doesn't really play a role in Danish phonology at all, at least in standard Danish. There's overt variation in the realization of the aspirated alveolar plosive, but this isn't something that's dealt with in the literature. Standard Danish is known to have a highly affricated variant, which is generally transcribed with a superscript S, whereas northern Jutlandic varieties use something that's popularly called a dry T with no affrication. This is at least folk-linguistically often attributed to northern Jutland, but it's been claimed by Brink and Lund that non-affricated T is in fact the norm throughout the Jutland Peninsula. I did a pilot study a couple of years back, which found that neither Brink and Lund nor the received folk knowledge in fact matched the reality. While dry T, non-affricated T, is found in large parts of Jutland, there are also traditional dialects that do have significant affrication. And there's no such thing as a categorical distinction here between non-affricated and affricated. I also found that VOT and burst characteristics are highly correlated, but not perfectly so. Recently, Eleanor Chodroff and colleagues found that there's covariation in voice onset time and in place cues of stops across laryngeal settings and across places of articulation, which basically means that within speaker and within variety, within language, you'd expect to find covariation for example, bilabial stops and voiceless unaspirated stops, etc. This means that even though we've only found overt variation for the alveolar stop in Danish, we should expect to find similar patterns for other plosives as well. And it's not really surprising that the overt variation is found for coronal stops, since coronal burst characteristics are just inherently more salient than other places of articulation. So we went into the current study with these hypotheses: that the received knowledge about T variation in Jutland does not give a full picture of the actual variation, and that T is not the only plosive to show regional variation. There's a growing body of literature in usage-based phonology that suggests that underlying representations are in fact emergent from the pool of synchronic variation. If we take this at face value, we should expect that patterns of so-called free variation in simple onset will to some extent correlate with phonological patterns in other positions of the syllable as well. For this study, we looked at 213 recordings from the Jutland Peninsula, as seen on the map to the right here, which essentially makes up all recordings that we have from Jutland of sufficient quality, with the caveat that we only used one recording per location. For each of these recordings, we segmented between 70 and 100 plosives in simple onset position. And from these, we extracted voice onset time, and we extracted for the fortis stops mean center of gravity throughout the release. Except in the final study here, we excluded tokens which had very short VOT or very low mean center of gravity. This gives us around 17,000 stops for our voice onset time study and around 10,000 stops for our center of gravity study, with a couple of thousand stops from each phonemic category, except a bit less for P and a bit more for T and K. In our COG study, we excluded a couple of hundred tokens from each phonemic category, but not enough to be, let's say, really worrying. For each of our tokens, we noted down phonetic environmental effects and speaker information that's known from the literature to influence voice onset time and center of gravity. This includes a number of features of the following vowel, the presence or absence of palatal release and stress, and the gender of the informant. We then fitted this data to generalized additive mixed models, which is a type of nonlinear regression model that's used for data that varies dynamically rather than linearly. In linguistics, these GAM models have often been used for data that varies dynamically across time. So this could, for example, be pitch trajectories, which vary dynamically rather than following a straight line. But here, of course, we're looking at data that varies dynamically across geographical space. We also added the speaker and environmental information I mentioned as linear predictors. We added random slopes by phoneme for the individual informants. And we included geographical information, latitude and longitude values, as smooths, so that's nonlinear predictors. In the COG model, we also modeled the influence of VOT on COG with nonlinear predictors. In our VOT model, all linear predictors, except for gender, were highly significant. There are several studies which suggest an interaction between rounding and place of articulation and backness in place of articulation, but we didn't find any evidence of such an effect in our data. For both fortis and lenis stops, we found evidence that labial stops were significantly shorter than alveolar stops, but there's no significant difference between alveolar and velar stops in our data. We also found a strong main effect of geography, in addition to specific geographical effects for the fortis stops. And the geographical effects are mapped here. On these maps, you see dark blue colors corresponding to low fitted VOT values, and bright yellow colors corresponding to high fitted VOT values, with the green colors somewhere in between. And on the main effect map here to the left, you can see very short VOT values found in the center to the west of the peninsula, with very high VOT values found to the east, and values that are somewhere in between in the far south and the far north. which isn't quite what we would expect from the received folk knowledge. What you see on the phoneme-specific maps are very similar patterns, which is something more like what we would expect, with very short VOT values in the far north, long VOT values in the far south, and basically an unbroken continuum in between. But recall that the phoneme-specific maps must be read together with the main effect map. In our COG model, we found that all linear predictors were highly significant. We also found a strong main effect of geography, but with no specific phonemic effects. We also found a significant dynamic relationship between VOT and COG. And here we have a strong main effect and a phoneme-specific effect for the alveolar stop. And this is mapped here. So what you see here is that we have high COG values, which means a lot of affrication in the south and in the northwest of the peninsula, with very low values, so very little affrication, so the far north and in the center of the peninsula. And parts of this correspond to what we would expect from the received knowledge, and parts of it don't. To the right here, you see a plot showing the relationship between center of gravity and voice onset time, which does show a relationship that COG increases as VOT increases, but it also shows that this relationship is dynamic, namely that as VOT becomes longer, this effect gradually plateaus. And recall that the map that you're seeing to the left here is taken from a model that already has the influence of VOT modeled as well, which means that what you can see here is the COG effects that can only be attributed to geography and that can't be attributed to voice onset time. If you're interested in more details about these statistical models, they can be found in the appendices of our handout.
On the basis of these results, we can form certain hypotheses about phonetics predicting phonology. We focus on lenition, mostly in the form of probabilistic spirantization, weak prosodic positions, namely in the coda position, and in unstressed onsets. Since occlusion is tighter for Fotis plosives, the Lennes plosives are expected to spirantize more frequently through gestural weakening. Specific hypotheses can be formulated for VOT. So for VOT, our general hypothesis is that a low VOT entails a laryngeal distinction that is partially maintained through pre-voicing rather than aspiration, and that this may entail phonological voicing. We have not measured pre-voicing systematically, but it indeed seems to be the case that there is pre-voicing when there is low VOT. When the Lennes plosives spirantize, they are expected to retain voicing throughout, and thus spirantize to voiced fricative rather than voiceless fricatives. On the other hand, if VOT is high, we have no reason to suspect that there is phonological voicing in the dialect. So when the Lennes plosives spirantize, we expect to find voiceless fricatives. Our general hypothesis for center of gravity is that when COG is high, we have very salient place cues during the release, because the place cues, or because the release resembles fricatives with the same place of articulation as the plosives. These salient place cues then increase the likelihood of reanalysis as fricative through cue re-ranking, or they increase the likelihood of dropping the occlusion in certain environments. If center of gravity is low, on the other hand, the Fotis plosives should be less likely to spirantize and thus be stable throughout. This high-low dichotomy is a useful simplification to us because it gives us 4 logical possibilities to explore. We explore these reduction patterns in the speech of 4 speakers who we deem are somewhat representative of the patterns we find in certain areas. And these findings are supplemented by findings from the dialectological literature on Danish, but it's worth noting that we don't claim that they are representative in any statistical sense. It's just our impression that these are representative of the patterns that we find. The first speaker that we investigated is from the village of Toftlund. This village is located in southern Jutland, an area generally characterized by high VOT and high COG. We expect that high VOT signifies a lack of underlying voicing, meaning that Lenna's plosives spiralize to unvoiced frigatives. Due to high COG, we likewise expect the Fortis plosives to spiralize to unvoiced frigatives, causing laryngeal neutralization. And we do indeed find laryngeal neutralization in the speech of this speaker in the velar plosives. In the coda position, the distinction between Lenna's and Fortis velar plosives categorically neutralized to unvoiced velar frigatives, and a similar pattern is found in most dialects of southern Jutland. We find the same pattern non-categorically in the onset of unstressed syllables, and there are examples to be found in the handout of this. There is likewise frequent reduction of the Lenna's bilabial plosive to an unvoiced frigative in the coda position, and these findings generally align with our hypothesis. The next speaker is from the village of Ørsted, located on the peninsula of Djursland. This dialect is the closest we have to an area with high VOT in combination with low COG. The patterns observed are somewhat ambiguously. Phonetically, since VOT is not super high and COG is not super low, and phonologically they're somewhat ambiguous as well. We do not find laryngeal neutralization in the dialect. For the Fortis plosives, we find that they are rather stable, as we could expect given the low COG, and likewise are the velar Lenna's plosives. We found frequent reduction of the bilabial plosive to an unvoiced frigative in the coda position, and unexpectedly we find a frequent weakening of the alveolar Lenna's plosive to glides, especially in some function words where the reduced form seems to be the lexical form. In some, the findings in Ørsted only partially align with our hypothesis. The village of Nord is located in an area of Midwest Jutland generally characterized by low VOT and high COG. As expected, given the low VOT, we do not find laryngeal neutralization in this dialect. The velar Fortis plosive frequently spiralizes to a voiceless frigative, and so does bilabial plosives, albeit less frequently. A reduction of Lenna's plosives to voiced frigatives or approximant is quite frequent, especially the velar plosive, which has categorically weakened in some function words. And these findings are very much in line with our general hypothesis. Lastly, Jungel is a village on the peninsula of Salling, where low VOT and low COG is found. In line with our hypothesis, we do not find laryngeal neutralization in this dialect. Spiralization of Fortis plosives is limited to the velar plosive, where it is found quite frequently. The alveolar and bilabial Lenna's plosives alternate with voiced frigatives, and interestingly, the alveolar and velar Lenna's plosives have a high frequency to assimilate with adjacent nasals, which would be an argument in favor of the presence of phonological voicing. Although we did not predict spiralization in Fortis plosives, the findings here also mostly align with our hypotheses.
Summing up our claims about possible phonological representations here, we suggest that the phonetic distinction between low and high voice onset time corresponds to a phonological distinction between presence and absence of voicing in the Lenna's plosives, and that this phonological feature is relatively stable in Lennician processes. We also suggest that the phonetic distinction between low and high center of gravity corresponds to a phonological distinction between absence and presence of place features during the release of the Fortis plosives. This can help account for the relative stability of the plosives, but it's difficult to capture at a phonological segmental level. A possible solution to this may be to use a representational framework that has a quantized view of the segment, like the framework of Q-theory. And we have some examples in the handout of what Q-theoretic representations of these contrasts might look like. So summing up, we've used a large corpus of interview data to show complex dynamic patterns of variation in the realization of plosives in the Jutland Peninsula. This variation isn't, as previously expected, limited to the alveolar aspirated stop, but applies to at least all Fortis plosives. We suggest that the phonetic variation that we see in Fortis plosives predicts phonological patterns for all plosives of both laryngeal settings, and that these patterns suggest differences in not only phonetic realization of the plosives, but also underlying phonological representations in the varieties. And we've supported this by showing patterns of clinician in the data that correspond to these hypotheses. Thank you for your attention.